everyone, welcome to this lecture. In the last lecture, we studied entirely the introduction of organic compound, then the characteristics of carbon, catenation, hybridization. In this lecture, we are going to study everything related to structural representation of organic compound. But before proceeding with the topic, let us quickly solve the question which I had given you in the previous lecture. Now the question is, find the hybridization state of each carbon. Now, in order to find out the hybridization state, let us first try to write down the structural formula. Okay, structural formula means I'm going to just simply expand the structure. Okay, and then we are going to identify based on the sigma bond. Now, quickly, I'm going to write down the tricks. For sp, the number of sigma bonds, it should be 2. Then because 1s and 1p is 2. For sp2, it should be 3 sigma bond. And for sp3, it should be 4 sigma bond. Clear? Now, quickly, I'm going to expand. This is C carbon. And on this carbon, we have 3 hydrogen. 1, 2, and 3. Over here, carbon, 2 hydrogen. 1 and 2. Then carbon, 1, 2, and 3. Clear? So this is the expanded form of the first structure. Now, after this, quickly we are going to write down the number of sigma bond. Now, the first carbon, okay, let us try to number this carbon. This is the first carbon, okay, let us number. This is the first carbon, second carbon, third carbon. Remember the numbering only for the explanation part, only to make you understand in the simpler way. I'm writing the numbers, okay. Now, how to put the numbers, position correctly, everything we will discuss in the next topic, that is the IUPAC name, okay. Now, the first carbon, students, you can see there are total 1, 2, 3 and 4 sigma bond. Okay, 4 sigma bond. So, the first carbon is sp3. Okay, the first carbon is sp3. The second one is also 4 sigma bond. So, the second one is also sp3. Then again the carbon, third carbon, it is again sp3. Okay, so in short, remember, if it is a single bond, okay, in a compound, in a carbon and hydrogen containing chain or a compound, if only a single bond are present, then all the carbon atom will be sp3. Okay, this is the shortcut or the best trick. Okay, coming to now the second structure. I'll just erase out, but before erasing, quickly take a screenshot of it. Yeah. Now coming to the second structure. Now the second structure is CH3, single bond, CH. Okay, so likewise, we are going to draw the structure one more time. C carbon, okay, hydrogen, hydrogen, and hydrogen. I'll number this carbon as well so that it becomes easy for me as well as for you to understand. Okay, now this is the first one. Then the second carbon, it has a hydrogen, only one hydrogen. Then between second and the third, there is carbon and then again one hydrogen, then carbon, okay, hydrogen, double bond, CH2. Okay, I'll just number this one more time. So the numbering is 1, 2, 3, 4, and 5. Okay, this also I'm going to expand. Now this is a CH2, right? So the CH2, I will be writing 1H here, and then there is a space, so I will write down over here. Okay, now quickly we are going to start writing the hybridized state of each carbon. Now the first carbon, total 1, 2, 3, and 4. 4 sigma bond, that means this is sp3. Okay, the second carbon, 1. And this is already I have written, okay, this is 2, then this is 3, because in double bond, one is sigma, the other one is pi. Okay, so only 3 sigma bond. So what will be the hybridization state of the second carbon? It is sp2. Okay, it is sp2 because 3 sigma bonds are present. Now the third carbon, again, the third carbon, it has 1, 2, and 3. So the hybridization state of the third carbon is sp2. The fourth carbon, I'll use some different color. Okay, the fourth carbon, 1, 2, and 3. Okay, because the double bond, it has one pi bond also. So this will be the pi bond. And we are considering only and only what, students? We are considering sigma bond. So this carbon, it will be sp2. Okay, and then the fifth carbon, again, fifth carbon, there is 1 sigma, 2, and 3. Then the fifth carbon will again be sp2. Clear? Okay, so this is how we are going to solve the type of hybridization state for each and every carbon. Clear? So I'll quickly write down the answer one more time. Now this is sp3 because single bond is present. If double bond is there, then sp2. This is also sp2. This is also sp2 and sp2. And in the first case, all were sp3 because of a single bond. Okay. Now let us have a look on the third structure. So quickly, I'm going to expand the structure. Okay. And then we are going to solve. Now the structure is carbon, okay, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. I'll quickly number it. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, coming to hydrogen, the first carbon, it has 1, 2, and 3. The second carbon, it has a triple bond, okay? The second and the third. The fourth carbon, 1 hydrogen. Then the fourth and the fifth, it has a double bond. Fifth and the sixth, here 1 hydrogen. Then your 2 hydrogen, okay? Then the seventh and the eighth, it has triple bond. And then the last one, it is hydrogen, hydrogen, and hydrogen. Okay, now I have expanded the entire structure. Now comes the hybridization. Now the first one, sigma, 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 because only a single bond. So this is sp3. Okay. Coming to the second carbon. Now second carbon, it has 1 sigma. Already I have written 1 sigma. And then in triple bond, remember in triple bond, 2 pi bonds. Okay. These are the 2 pi bonds. And then this one will be sigma bond. Because the overlapping, whichever takes place linearly, that will be sigma bond. Okay. In case of triple bond or alkynes, remember, 2 bonds are overlapping parallelly. So this is the pi bond and only 1 sigma bond. So 1 sigma bond is here. So total on the second carbon, 2 sigma bonds. So how 2 sigma bonds means it is sp hybridized. Okay, it is sp hybridized. As you can see, it is sp hybridized. Okay, the state. Coming to now the third carbon, already 1 sigma bond is present on the left hand side. And then the second, again, this will be what? This will be sp. Okay, remember now the trick is if single bond is present, sp3, double bond is present, sp2. If triple bond is present, then it is sp. Okay, this is the shortcut method I've told you. Now coming to the fourth one is 1 sigma already written, then 2 sigma and 3 sigma. So again, this will be the hybridization state will be sp2. Just now I explained you, I shared the trick, double bond, then it is sp2. Then coming to the fifth one, the same trick, double bond on the left hand side, so it is sp2. The sixth one, all are single bond, then it is sp. Okay, the seventh, triple bond, then quickly you're going to, this is sixth is sp3. Then the seventh, it is sp. The eighth, again, triple bond, sp. Fourth, it is single bond, so it is sp3. Clear? So this is how you are going to find out the hybridization state of any carbon. Okay, you take any organic compound, be it a single bond containing, double or triple bond containing compound. You can easily use this trick and find out the hybridization state. Clear?
Thanks for watching. If you found this helpful, don't forget to like this video, subscribe for the full course and drop your question in the comments. And don't miss the next video in this series. It's linked right here on the screen. Keep learning and I'll see you in the next one.